Okay. So a lot of the things that we, hear, a lot of problems we hear about are things that can be resolved and things that I'm sorry to say are never going to get resolved. There's one that makes me despair. An email makes me despair, usually written in all caps. My hands hurt from pressing the stone down, trying to get it to polish. Look, this guy isn't going to get it. Usually more pressure, more speed, more polish isn't the right answer. If you have to use that much force to push a stone down, something's terribly wrong. One of the most common ones is the lap is too wet, it's hydroplaning. Anybody know how a Babbitt bearing works? A journal bearing? There's a guy who invented this metal, which is related to a lot of the cast metal laps that we're using now on similar principles. Anyway, this guy, I think he was in Rhode Island, his name was Babbitt, and he sees a shaft running on a journal bearing, and oil's coming out the hole. So he looks and he put a cork stopper in the hole. And he started the machine again, a cork stopper blew out. So he drove a wooden peg in the hole. Wooden peg blew out. So he did what he should have done in the first place, he put a pressure gauge on it. And looked at astounding pressures were being developed. This is what happens in hydroviscous shear when you have too much oil on a lap. The stone is not, it isn't seeing the polish, it's seeing an oil film. And it doesn't matter how hard you press, you'd be amazed at the pressures, thousands of pascals that can be developed between those two surfaces. So we found out only a couple of years ago, with one of the laps I made, that everything I always knew was wrong. In the case of 3K pre-polish and 50K polishing, I found out that use almost no oil at all. Everybody see the video on the back page, the charging video? Well, it pretty much shows that only a tiny bit of oil is used, and all of a sudden people are getting great results. And this is going to be true, not for the things I make. I don't want this to be an infomercial. It'll work with tin lead and anything else out there, 95.5, pewter, whatever. So those are some of the things that go wrong. Now, in the case of things that go right, we have two choices of doing it. We have the diamonds and similar materials like boron carbide, which is finer and finer scratches, supposedly. We go down to a point where we're less than a quarter micron, and the scratches aren't supposed to be visible. In the case of diamonds, though, this dry film method doesn't use the entire width of the diamond. And in the case of bonded diamonds, a person who is a diamond dealer for the optics company I work for explained it to me. When a diamond is embedded in something, its diameter isn't generally available to do the cutting. So the scratch size is about 1/2 the diameter of a particle maximum. The other mechanism, as we all know, are oxides. And a lot of people will use nothing but for a final polish. And oxides are a special case. They don't really scratch, they don't really rub, they don't really dissolve. It's a very complex mechanism that hasn't only been studied for the glassy materials like quartz and the glasses, optical materials, because that's where the funding is. There's an issue called specificity, where there's something magic about cerium oxide and quartz, everyone in oxide. But you might take something else of a similar hardness and say, well, cerium oxide should work with that too. It doesn't always. It's one of those strange things. Because the group is small, I'm going to just let this freewheel. Anybody with questions or comments, I'm going to depart from my script. I'll keep going if you want, but anybody want to comment at this point, they're welcome to do so. Anybody want to add anything, they're welcome to do so.
Briefly talk about the reason for using an oxide after diamond. Good point. As we say, with the diamonds, it's finer and finer scratches, okay? And supposedly you could get down to a fraction of a micron in an RNS finish.
then you're below the resolution, the diffraction limit of light, and supposedly, you can't see the scratches. But there is a sleeky appearance to it, and there's something else that goes on. And when you follow that up, like for instance, suppose you cut a sapphire, and you use quarter micron diamond, and it's going to look beautiful. But if you take another one for the same material, and you cut that, and you use a kiss of aluminum oxide, Lindy A, after that, and you show it to somebody who isn't even a gem cutter, just sitting next to each other, this indisputably, the one with the oxide is brighter. And the reason it's brighter is that even though the physical explanation of the diffraction limit doesn't apply, what does change is the scatter coefficient of the surface. If one is a series of scratches that are even a fraction of a light wavelength, there is still scatter going on. And in other words, white and black tend to look gray. That's what I mean by the contrast index. And the one that's been done with the oxides is down to the structural limit of the crystal itself, the lattice. And in that case, you look at it, and the highlights are brighter, and the facets that aren't reflecting are darker, more saturated blue. That's the best argument. And I think that most people would compete, insist on ending with an oxide, even if the diamond polish is beautiful. I mean, a lot of the people I deal with the commercial cars, okay, and they're bought the stopwatch. And in that case, we have people that want to skip as many stages as they can because the clock is running and, they're paid so much per job. That's different. But generally speaking, a person who wants to do a craftsman-like job, it will follow up on an oxide because the oxide finishes are beautiful. They're as good as you can get. I was going somewhere with that too. Oh yeah, the reason why we talk about polishing so much and not the cutting end of the operation is that generally we have designs, or we've cut a lot and we simply know where we're going. And to cut the stone and shape it is a numerical recipe. Okay, 93.3, blah, 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 blah. At so many degrees, and then, and so forth. That's a good technician. You're translating numbers into a solid, object. The craftsmanship comes in when you're polishing. And the reason why is that the polishing is experience and touch sensitive and very hard to define. If it were easy to define, we wouldn't have had all these discussions over the years, and me and other people that manufacture things wouldn't be getting all the emails all the time. Now, I get about 1,000 emails a month. Half of them are nonsense, personal things, jokes about how getting old is funny. I'm going to kill these people. Some of them are forward this to everybody, but an awful lot of them have to do with polishing. They still do. And even before I was making things to polish with, everybody talks about it. And the reason why is it counts. Is it's still touch. It's still listening to the lap. The divine intervention. No, okay. It's you know that you listen to the lap. You feel what the drag is. You feel how much work you're putting into the facet. The polishing rate depends on the work that you put into the facet. In principle, you shouldn't be seeing the lap. You should never see the stone. The lap is merely a propulsion medium for the polish, no matter which it is. That's why the ceramic laps work. The ceramic lap is as inert as you can get. And that requires a lot of skill, to get that touch for them. But they're not going to do anything. It's the only lap that's harder than most of the stones that we cut. And if you can acquire the skill to use one, they produce beautiful dead flat facets. Some of us never acquire the skill. I have to admit that I didn't. I used to use one all the time at work in the metallography lab. And I could use them fine. I get good results in my samples. I go home in my own shop, I could just never figure it out. And that's one of the magical things about polishing, is that we all have, everybody who sells laps, everybody who makes laps, always gets a situation where somebody cannot make them work. And it's no reflection on the person. I've had people who are AGTA award winners that cannot get one of my laps to work. There's nothing wrong with the people. It's just that people develop their touch and style and their way of interpreting what the lap is telling them. And they get it perfected. And when they, oh, there's something new, I've got to try the new thing. And sometimes you can't use the new thing the way you use the old thing. You know, so that's why there isn't a lap manufacturer in the world that hasn't seen a post saying, anybody wants to buy this damn thing for 50 bucks, you know, email me. I don't like getting those. Nobody likes seeing those, but you know, you got to realize that that's the way it is. And one of the most exasperating things is sometimes a beginner will buy a new product and sit down and go, hey, this is fun. Wow, look at this. I just finished a stone, the whole stone, 54 minutes front and back, you know. And you get somebody else who, you know, just won some championship somewhere, who writes me, So, you know, that's why we always talk about polishing, why we're always going to be talking about polishing. Generally, though, it looks like things are settling down. It looks like people getting things figured out more and more. But, you know, next year, or the year after, there's going to be a new polishing lap on the market, and new polishes on the market. And there always will be. They won't be coming from me necessarily, but they'll always be out there because polishing is the holy grail. It's the one thing that people, you know, have trouble with. And the worst part is that you can sit down and you can see someone finish a stone and write and make notes and everything else, and when you go to duplicate it, how many people have noticed? It just doesn't come out the same. Yeah.
When you go back to the basics,
yeah.
Okay, the guy that's feeding his chickens,
yeah, right,
and is able to get a better polish than I can get.
Oh, no, I wouldn't do that. Good Lord, a room full of facets, I'm going to tell them that. No, I'd be lynched. No. What I'm saying, though, is you're looking at it, it's really not as bad as you'd expect, the polish, very often.
What's he doing?
What's he doing? I'll tell you one thing he's doing that we don't want to do, is he's using chrome oxide, and the shops are green. Ask anybody who's been to Brazil. I know one person who wasn't allowed back to his local fasteners guild because he brought some chrome oxide one day and, you know, did a paint job on the place. And it's one thing they do, and they're also pragmatic. Once they find something that works, and if it's something, you know, if it's a tin lap at 3,600 RPM, I'm just picking that number because it's outrageous, and it's chrome oxide, then that's what they're going to use every single day. No changes, you know, because after all, they're producing. I mean, some of us cut 50 different materials, okay? These people are focusing on quartz, you know, and of course the barrels are very easy. They're so easy that, you know, no, I'm not, I don't think I've ever seen anything that I bought, you know, wholesale, you know, the bellied stones, and the ones that, no, we're talking, we're different, Nobody's paying us to fill a coffee can full of stones that day. You know, I wish they were, but they're not. It doesn't work that way here. Anything else? How am I doing? Oh, all right, I filled up my half hour.
Now we can talk about anything we want.